Hey guys, welcome back to another video. So today is going to be a little bit of throwback from 2 years ago. And it's about it's another scientific video that, I cannot believe I'm saying this, but doing another scientific video 2 years later. Basically, back then I did a couple of them, I was experimenting. Small part of it was for the view count, but I wanted to express some of the theories that I found interesting. So how large are a Google and a Googleplex? How many doublings of a Planck volume does it take to take over the universe? And finally, which is my third video, this is my last one I did, which was still 2 years ago, is it possible to walk 1 light second in a lifetime? So today, I decided to come up with a new video. This is actually a video I had pending. I should have had this uploaded last year, but now I'm finally having it ready to go. So basically, this video is, theoretically, everything you see around you is 3D. So basically, what I'm trying to say is 2D or two-dimensional doesn't exist. This world has nothing two-dimensional. Everything you see, everything around this room that you see, or everything in front of me, or anything that's around me, or anything around you, is three-dimensional. There's no such thing as a two-dimensional thing. And actually, so I was up a little bit at night. I was writing the parts of the video, no script. I was just writing down the segments of the video of the topics. And I actually have the topics they're actually right here, on this little sheet of paper, but the paper is actually going to be part of the video because it actually is part of the topic for one of them. Yeah, so basically it's going to be really interesting. I found some really interesting stuff about if something was actually two-dimensional. All right. So first, I'm about almost 2 minutes into this video. If anyone is new to the channel, want to stick around for more videos like this or more Pokemon cards, because I'm currently almost at 100 Pokemon card videos, which is crazy to think about. So again, if you guys are interested in, want to stick around, subscribe to the channel. And also, by the way, we're still at 286, but I haven't uploaded in a while because, well, school. So it's okay. And we have only 14 more to go to 300. And I think I'm going to be doing a Silver Tempest booster box for 300 subscribers, but I'm not for certain. Because, by the 12th, I know it's coming out the 11th, but the 12th is when I'm probably able to get the box, depending on how good of a deal I get. If I get it cheaper from somewhere else, I'm probably going to get it from somewhere else. All right, so and also I would say if we hit if we're at 290 something by the 11th or the 12th, I rather if we get there a little bit late, that's fine. I mean, I rather because if it's early, I rather I'd have to keep you guys waiting a little bit, but it's all right. Also, guys, again, drop a like on this video. I don't know if what a like. We don't really need a like for this video. If you guys want, just drop a like. If you guys found this interesting. All right, guys. So let's get started on how everything in this world, even the universe, is three-dimensional. Alright, so our first topic of the video is, well, as I said, a sheet of paper. So, in terms of context, especially at a young age, and honestly this really doesn't matter, you could call a piece of paper two-dimensional. I mean, look. So, that's fair enough, but if you're talking scientifically, a piece of paper is still three-dimensional. I mean, you could mistaken it 11 inches by 8 inches, and that's its 2 dimensions. But what if I told you you're looking at the sheet of paper wrong? If you look at it like this, which, yeah, granted, it still has its 2 dimensions, but technically, this sliver right here is still a third dimension. Even if that dimension is micrometers, which it's less than a millimeter for sure, but micrometers thin, the paper would still be, well, it wouldn't be exactly this, 11 inches by 8 inches by, let's say, 100 micrometers. It wouldn't necessarily be 100, they would have to convert that to inches, but that's basically what I'm trying to say. It still has a third dimension. The piece of paper is still three-dimensional, despite that third dimension being extremely small. So, okay, our second topic, which is actually kind of a subtopic to the sheet of paper, is what if I wrote something on it? Or what if I went on Google Word, or just Word, and typed, let's say, the letter R? So basically, the letter R, and then I'm going to print out the paper. So, obviously, you're going to see, the letter R on that one side of the paper I printed. Well, okay, so the R has to be the same dimensions as the paper, right? Or maybe the R really is two-dimensional. That's actually wrong. Because the R, let's just say on this, so let's say if I did an R, if I wrote an R right here, and then I'm going to flip the page over, and once I flip the page over, you'll still see the reversed, you'll see the R in reversed. It's like a reverse version of the R, but you'll still see it peek out through the paper. That means it's not exactly the sheet of the paper. I mean, it's not exactly the width of the paper. It's about a fraction of the width of the paper. But keep in mind, even a fraction of the width of the paper is still a distance, making it still a third dimension of the R. Let's say if the R was half a cent or like a centimeter by a centimeter, and the piece of the paper or half the sheet of paper is like 50 micrometers. It's still a third dimension of the R. This is what I found interesting about this. The R, if the R was really two-dimensional, the R, let's say if this was the back side of the paper. If I drew the R on this side of on the other side of the paper, you would actually not see the R, or not even the reverse R on this side of the paper. It wouldn't be there. But for that to happen, the R has to be infinitely thin. And obviously, that means 0. But obviously, that doesn't exist. The R, no matter how small, it still has a bit of distance. All right, so that's the letter R in the sheet of paper, but let's take this a little bit further. All right, so our next topic is like, it's kind of a weird one, but it's gonna like, you gotta like picture this in your head kind of. So picture an imaginary cube. The cube has dimensions of, so it's obviously a cube is length times width times height. So let's say it has a length of, just don't pay attention to this. This is not a centimeter. So 1 centimeter of its length, its width is 1 centimeter, and its height is 1 centimeter. So what if we shrunk down this cube, all three of its dimensions down to a Planck length? And to those who don't know what the Planck length is, basically it's the smallest unit of distance possible in the universe, being 1.6 times 10 to the negative 35 meters. To put that into perspective, let's just picture this. 0.33016 meters. Imagine how small that is. But even in that, like, since all three dimensions are the same, a Planck length is still a part of a distance. It's still a piece of distance. That means it's still 3D. I mean, look at protons, neutrons, and electrons. They might be femtometers in size, or quadrillionth of a meter. Yes, this is a reference from the Planck length video for the taking over the universe. I do remember the formula, that a proton is a quadrillionth of a meter. But like basically, like even those, they're spheres. They're still 3D down at the quantum level. But basically, back to the Planck length cube, it would still be three-dimensional. But now let's revert the cube back to its original dimension. So 1 by 1 by 1 centimeter. They're all the same. But let's say we kept the length and the width the same, 1 centimeter, but we shrunk only the height down to a Planck length. Now what would happen? Well, believe it or not, despite this, like, I guess, cube would be so unimaginably thin. But if you were to like right here's the table. Let's say if you were to look right down at the table, and like you see this, let's say that it's like a red square, you would actually still see. You would still see it. It would still be visible to the naked eye, despite the thinness being so tiny. It would still be possible to see. But like, I guess it'd be close to invisible because it's so small. But it would be like, you have to do it like under like its perfect counterpart color. So maybe like under like, maybe like on a black table, you would barely see the red seeping through. But keep in mind that that Planck length is still a third dimension of the cube. All right, and now the last subtopic of this is the subtopic of the video of the imaginary cube. What if, so we kept the same dimensions, 1 by 1 centimeter, but now the height, what if it was smaller than a Planck length? Now, honestly, this can go two ways. I would say, so the first thing is, it's still a finite distance, and let's say if we shrunk this down somehow, like, this is not possible in the universe, 1 times 10 to the negative 100 meters. And this is actually, I can't even explain how much smaller this is compared to a Planck length. Imagine taking out the 1/6, okay, obviously, 0.99 zeros than a 1. Adding 65 more zeros to the end of the Planck length, and then putting the 1. Believe it or not, that's still distance. It would still be 3-dimensional. 1 centimeter by 1 centimeter by 1 times 10 to the negative 100 meters. It's still a thing. But that's if you even did the theory. Because if you were to do this, if you were to look at this literally, anything smaller than the Planck length really doesn't exist. Or it could, but the laws of physics break down. So theoretically, the Planck length is still the smallest unit of distance possible. Now, this is like another thing I want to talk about. It's kind of like an extra small thing, but I didn't put it like as part of the draft. So basically, what about digital things? Like if you're like over there, which is the desktop that I use for editing PowerPoints and stuff like that. This PowerPoints is just my kind of another hobby of mine. I don't really share it. But basically, what if let's go back to the letter R. If I were to still type the letter R on a sheet of paper on, let's say, Word, what about the R on the computer screen? Okay, well, it would still have its 2 dimensions, length and width, but would it still have a height? Now, maybe not. Maybe stuff in the computer and on any screen, maybe even the screen you're watching right now, me talking about the video right now, that could be 2-dimensional. But here's the thing. The catch is, that's not physical. It's digital. If we're talking about the physical world, nothing can be 2-dimensional. Two-dimensional on a digital screen, that doesn't really count. Because, the screen could be infinitely flat. The inside of the screen can be infinitely flat. So, and also, another little part of this, if, let's say, the imaginary cube or the sheet of paper were to actually be 2-dimensional, so 1 centimeter by 1 centimeter for the cube, or 11 inches by 8 inches for the paper, but let's say there was no third dimension, so basically, or saying that dimension was 0, believe it or not, this sheet of paper, I wouldn't even be holding it in my hand. It wouldn't exist. Because if this was actually 0, this would disappear. Therefore, the whole paper will just disappear. Now, the thing I don't know is, would the paper still be there? That's a good question. Would it be invisible matter? Or will it just disappear? Well, assumingly, most likely, it's probably going to disappear. Because its 2 dimensions would also disappear because if a dimension equals 0, it's like multiplication or division. If you divide something or multiply something by 0, it automatically equals 0. Even if you were to do a million, a billion, a trillion times 0, or a trillion divided by 0, it would still be 0. All right, and there you guys go. That is my thoughts, or my my theory on nothing in the physical world is 2-dimensional. Alrighty, guys. So that's gonna be for today's video. I want to say, guys, I thank you guys for tuning in. It was actually kind of a blast talking about this. Me talking about this in front of the camera was actually a lot more exhilarating than I can imagine. It was better than I was actually practicing right now, walking around the room, saying the whole outline of the video. All right, so if you guys are new here, once again, you guys want to stick around for more videos like this, or Pokemon videos, or any other videos in general, subscribe to the channel. Our next goal, 300 subscribers. And again, sooner or later, we're going to be getting Pokemon Sword and Shield Silver Tempest, which is looking like a fantastic set. And hopefully we'll be doing a booster box for 300 subscribers. I was supposed to do this for 250, but we got to 250 so fast that I couldn't do it. So maybe 300 is the goal we'll do here. And also, guys, I've been seeing a lot of new leaks about the last Sword and Shield subset, Crown Zenith, or Crown Zenith. I don't know which one it is. Oh my gosh, I about fell in love with the set. 70 trainer gallery cards, or like a 70 subset. 70 card subset. Okay, and yeah, I'm well aware, yeah, Cynthia's a full art card and all that stuff, but honestly, that's one flaw, and I really don't care. The set is just it's still a 10 out of 10 in my opinion. I'm not going to go into further details, I'll probably discuss this in a later video or something, I might do so. Alright, so again, also, guys, if you guys want, please like the video. Again, there's no like goal. If you guys want to like it or not, if you guys found this interesting, then please do. I cannot believe to say how fast we gained. We're now only 14 subs away from 300. 14. And again, we haven't gone up in a while, but it doesn't matter because, you know, I have school and stuff, and I couldn't do videos. I could have did some shorts, but that's about it. Alright, guys, so for further information, I'll probably do a new video soon. Like, I might even do one tomorrow. I still have to do my driving lessons. He didn't come, like, right now. He was doing another road test for someone else. It's okay, guys. It's not a big deal. We're doing it at noon, which is, well, I just looked right there. It's 10:15, which is about an hour, it's an hour 45 minutes. So I'll have some time to at least edit some parts of the video. All right, guys. Thank you guys for watching this video. I'll see you guys in the next one. Peace out.